Hello, everyone. Thank you again for joining us today and taking the time to attend this webinar. So as you all know, this webinar is on relief sizing and not only the features that Aspen Tech provides in order to accommodate your relief sizing workflow, but what this webinar is going to do today is really take a technical look not only at the products we have, but also, the calculations that go into them and show some in-depth demonstrations of how to utilize our products to best fit your workflow, whether you do feed or revalidation safety analysis. So, before we dive right into the content, we just want to go over a few upcoming events that pertain to our relief sizing functionalities and safety analysis as a whole. So starting from a broad context, you all are here today, hopefully to learn about relief sizing and maybe some of the products that Aspen Tech has to offer. And one way that you can kind of extend this learning is via an upcoming conference. It's called Optimize for 2015. It's taking place 3 days in May. And not only do you have the opportunity here to learn more about our products through sessions that include demonstrations, but you can also discover and listen to your peers give presentations about how they actually utilized our products in real cases and learn more. Additionally, this opportunity is great as it provides the chance to really share your experiences or just network with other users or people within industry. We have sometimes, over 700 people who attend this conference representing 40 different countries, so it's a great experience. And we really encourage you to visit our optimize2015.com website and explore what we have to offer. Additionally, we also have opened up a call for abstracts. So if you think that you could share your own Aspen Tech relief sizing or general story, we highly suggest that you submit an abstract for that today. Now, looking a little more specifically at relief sizing, the topic we are focusing on today, we have an upcoming event in January 28th. This is another webinar, and it's the first of its kind. This is our Viewer's Choice webinar for safety. And what's so different and great about this webinar is that it's going to be very interactive. We know that, as a relief sizing community, you guys have a lot of great questions and topics you'd like us to cover, and we want to hear from you. So we're going to be taking your questions, your suggestions, the topics you want covered, and incorporating them into our presentation so we can, rigorously answer some of the top questions we get through the content of our presentation and have a great Q&A session after. So we'll get into more of the details of not only what this Viewer's Choice webinar is, but how you can get your voice heard later on in this webinar. And I just want to mention, as I said before, this is a technical webinar today, and we have a variety of different user levels attending. So we're going to get into the nuts and bolts of things. But if you're a beginner user and you're not as familiar with the functionalities and safety analysis environment we provide, definitely stay tuned and listen to what we have to say. And then after this webinar, we have a series of on-demand webinars you can, visit anytime on our website that will show you the basis and, build your knowledge. And if you're an expert user, these are also great resources to kind of build up that knowledge and really get it solidified. So with that, we're going to jump right into the presentation and the content of our webinar today. At the bottom of this presentation right here, you can see the flow of today's presentation. We're going to start off by addressing the safety analysis environment, or the safety analysis workflow and how Aspen Tech can help improve your workflow. Then we're going to get into the heart of our webinar, and we're going to take you through some rigorous, in-depth demonstrations that don't just show what we offer, but how to utilize our product fully and, the calculations behind it. Really, get under the hood, as Anam says. Then, we're going to go into the proven results and share the success that an E&C company, saw by using our product. Finally, we'll go into what the Viewer's Choice webinar is, and then conclude our webinar today with everyone's favorite Q&A session. So let's get started. As many of you are aware, there are many steps, that go into an pressure analysis and a relief sizing workflow, from when pressure is built up in the process to when a flare system is created to discharge relieving fluid. Now, these aren't trivial steps, and everyone wants to find the most efficient way to address each step. And that can start with all the way from simulating your process and going through to designing and rating that flare system. So we're going to go in briefly just to highlight each of these steps and kind of understand what the pain points are in your workflow and see how we can then improve them. So the first step in any process is to simulate it and really design your flow sheet, and often this is done through a simulation software. After you've designed your process, you then want to identify areas of overpressure and size your relief devices. Using just a simulation software with an external tool, you would then have to go in to your simulation, recreate your streams, bring them to relieving conditions to get your correct properties, then take that information and manually export it to an external tool to do your relief sizing. This step, brings up a few pain points because manual data transfer is, time-consuming, tedious, and, raises the probability that there could be some transcription error and data inaccuracy. So, once you've sized your relief devices in this external tool, again, you have to use manual data transfer to then bring that information to your, flare system software. Another step that requires manual data transfer, and that's a pain point that could definitely be streamlined in a workflow. Finally, once you have your relief devices within your flare software, you can then design and rate your flare system. So we don't want to harp on, just how to address the safety analysis workflow and the pain points of it, but rather talk about how you can improve this workflow. And Aspen Tech provides a variety of different features and products to address this, starting with, simulating your process all the way through to, design and rating your flare system. And so we're going to go into how these pain points can be addressed now. So the first step in your process is to simulate it. And many of you, as you know, are familiar. You use either Aspen Plus, Aspen HYSYS, or both, and you are aware of that product. What you may not be as familiar with is our safety analysis environment. So in this screenshot, we've highlighted with a green box one way to access our safety analysis environment. You can access it directly within the simulation, and we'll go into what that is a little more in depth now. So the next step in your process is sizing relief devices. And we've addressed this with our new safety analysis environment. And what this environment does is it really integrates within our simulation softwares a way to size and add relief devices. So remember before you had that manual data transfer, tedious workflow. However, with the safety analysis environment, you can combine both of your tools, your simulation external tool, together into one tool and eliminate that manual data transfer step. So if you're not as familiar with our safety analysis environment, this screenshot here shows what it looks like. As we highlighted before, the safety analysis, you can click on the button on the left side of your simulation to launch into the safety analysis environment. If you're a newer user, you'll notice that once you've successfully entered the safety analysis environment, the simulation is marked by a red ribbon. Don't worry, that doesn't mean you've done something wrong. It means you just successfully entered the environment and your major pieces of equipment are locked, so you don't have to accidentally worry about altering them. However, the benefit is you can now reference them side by side with your relief sizing form and size your relief devices while referencing your simulation file. So again, after you size your relief devices, you want to take them to a flare software. The benefit the safety analysis environment provides to your workflow is that you can now automatically export your relief device information to Aspen Flare System Analyzer. So what does this mean to your previous workflow? Well, that manual data transfer step that was, taking you too long before is now eliminated, and all of your tools are combined together into one automated step. So this is a great way to really streamline your workflow. Finally, so you have your relief devices and you brought them into your flare system. And so Aspen Tech covers this with Aspen Flare System Analyzer. And as we exemplified before, you can now import relief valve sources from either Aspen Plus or Aspen HYSYS into Aspen Flare System Analyzer as highlighted on this screenshot. Another benefit is you can now map relief scenarios from simulation to specific flare scenarios. And both of these points, we'll go over later more in depth in our demonstration. This is great because you can now complete, design and rate your flare system within our tool. So, just to finish up how Aspen Tech covers your improved workflow, we have an explicit list of all the features that our latest release sizing capabilities address. One thing I want to note is that all these features are available within the most recent versions of Aspen HYSYS and Aspen Plus. Our demonstrations in just a minute will all be done in Aspen HYSYS just for consistency, so we're not bouncing back and forth between two different simulators. But just so you know, all the features listed here are available in the most recent versions, and specifically if you're an Aspen Plus customer, the safety analysis environment was introduced into Aspen Plus in version 8.6. So you'll have to utilize version 8.6 to really see the benefits that we'll be demonstrating later. And just to clarify, the features highlighted in green are specific to version 8.6 for HYSYS and Aspen Plus. So if you really want benefits, we'll go over in the demonstration, including rigorous fire, relief load determination, and multi-valve analysis. We suggest you utilize version 8.6 because that's what's available in. So with this, we're going to pass the presentation over to Anna, and she's going to get into the nuts and bolts and really show you how to utilize these features effectively.
Great. Thanks, Catherine. So here in front of you, you see the 4 areas that I'm going to demonstrate. The first one will be the most technically in-depth. So first I'll discuss how the new fire algorithm works in version 8.6 of Aspen Plus and HYSYS. Then I'll go into how you set up systems that are protected by multiple relieving devices, how you take the results of your analysis into a flare analysis in Aspen Flare System Analyzer, and then finally, how can you take all of this input into a simulator and generate and customize documentation. So let's get started. I'm going to move into the software. Okay, so here in front of you, you should see a system that I've generated that just has a series of different feed streams coming in from different plant units into maybe a feed surge drum, for example. And the system is at designed for 55 PSI and 150 Fahrenheit. You'll notice that the operating conditions are taken based on the stream to which the relief device is attached here, so stream 5 from the simulator. If you're wondering how you access this environment, Catherine showed you that you click the button on the navigation pane that says Safety Analysis Environment. So I'm no longer in the simulator. Now, the next tab allows you to identify scenarios. I've gone through and I've identified some scenarios, you'll see why later, but they're traditional scenarios of blocked vapor outlet, blocked liquid outlet, total feed blockage, and any control valve failure openings. But for the purposes of this demonstration, let's discuss how a fire scenario would be created. So I just clicked the Create Scenario button, and that generated a new row in my Scenario Manager. So here, I want this scenario to be fire, because fire is applicable for any vessel under 25 feet in elevation. I double-click on the row to open up the Scenario Analysis screen, and this is where I can set up inputs to my scenario and where I get the outputs from the calculation. So what you'll notice is that my separator vessel has 2-phase feed that is going into it. Now, based on the tooltip, you can see that for the fire scenario, we recommend the feed to the upstream unit operation. So I click the override checkbox, and now I have to try to identify what the feed is to my separator vessel. Now I've simulated it as the combined feed here. So in the selector, I scroll down until I find combined feed, which is right here, and then I select OK. And what you'll notice is that the calculation method changes because there are two types of vessels that you could have, vessels that contain a liquid inventory and vessels that are vapor full. For vessels with a liquid inventory, the primary cause of relief is by the liquid vaporizing, so you need a different calculation method, and that's what we'll go into today. So one of the options you have for the calculation method here in the Dropbox is the wetted API. So this is based on API 521. We'll go into the actual equations implemented, but you get a lot of options. So people familiar with relief device sizing will know that sometimes you make conservative assumptions as a first pass to see, if the relief device needs to be exorbitantly large. Then you go back and you kind of sharpen your pencil if it's not appropriate. So here you'll see the default is 50 BTUs per pound for the latent heat, which API recommends if you have no clue what's in your vessel. It's very conservative. I'm going to go in and I'm going to type in my equipment dimensions. This is very important for the fire calculation. So depending on the stage of development you're at, you really want to try to get this right. So I'm inputting a horizontal vessel 5 feet diameter by 8 tangent to tangent length. And based on the data sheet, my level taps, I would put in the liquid level. And then my company guidelines, let's pretend, require only 10% additional area to account for any interconnected piping outside of the vessel. We also let you look at insulation, that's the F factor, but for the purposes of this, we'll just pretend there's no insulation, which is, again, the most conservative. It results in the largest relief load, and that requires 4.3 square inches. Anytime I make an update to any of the blue values, you'll see an automatic update to both the required relief load and the calculated orifice. That's a little too big for what I was thinking this vessel would require, so let's sharpen the pencil and estimate the latent heat. So here, I'll estimate the latent heat, but the default is 0 to 10%, but I think I have a really wide boiling point mixture, so I'm going to use a very conservative amount. I'm just going to use the very, very light ends to determine my latent heat, and you'll notice that the number changes. I just want the first mole percent, what the latent heat is there. And you'll see it's 111.6 BTUs per pound. That results in about 2 square inches of required orifice area. So then I want to sharpen my pencil more, and I know a lot about my vessel at this point, so I'll go to the semi-dynamic flash model. Semi-dynamic flash requires you'll note that you have to type in the equipment dimensions here. It's very important. And it requires you to be familiar with the algorithm. So I clicked the Edit Flash Table link, and what you want to do here is you're setting up a series of flash drums, 10 flash drums that'll go from the relieving temperature to this maximum temperature I specify. Now, of course, I've done this before, so I know that all of my liquid inventory will fully vaporize by 330 Fahrenheit. And the percent vaporized will indicate that. So at each time step, first I have 1% that vaporizes. By the end, I have the full 100% that's vaporized. You'll notice that the required relief load is about 6,800 pounds per hour. But maybe I want more exactness, so I increase the number of flash drums to 100. What I want to show you is that it actually doesn't result in that much of a difference to my required relief load. So here it is, the maximum, 6688. And it does require a longer time to calculate. So because it doesn't really impact my required relief load, I'll go back to 10 flashes. I don't need that incredible level of accuracy, and then I click OK. You'll notice that the required relieving flow is here and the orifice is calculated. Now it does significantly decrease the required orifice area, and that's why it's a good recommended calculation methodology, depending on what your company guidelines allow. Now let's go and take a look at what's really going on inside the calculation method. So here's a HYSYS or Aspen Plus safety environment fire algorithm. First, it asks the question, does your vessel have a liquid inventory? This is based on the reference stream that you select. I selected something that represented 2 phases in my separator, so that went down the yes path. So I had the wetted API 521 method and the semi-dynamic flash options. If I had selected just a vapor stream, it would have only allowed me with vapor methods, the unwetted API 521 calculation and the supercritical method, which is documented in a paper that I can send out if you're interested. The next thing that's the biggest calculation that impacts your results is the exposed area calculation. The assumption here is that there's a 2-to-1 ellipsoidal head. Now, if you have a hemispherical head, if you have any other different type of contortion, you really want to manually specify that number. Also, we do let you tell us if there's a skirt or not. So if you have a vertical vessel, and as you may know, if there's a skirt, you don't really have to account for the heat going into the bottom head. So you can select vertical no bottom head or vertical including the bottom head, depending on whether you have something that might block that heat input. Also, and I want to show you this, we do document fully all of these calculations. So if you're not in this webinar, or if you know someone that couldn't make it today, they can just click the F1 help from within the simulator, and it pops up into the online help. What you'll notice is that it takes you to how to define a scenario, but if you're interested in technical information, there's a full technical references section. And for the fire calculations, you'll see that we do document sort of all the relief load calculations and the equations that go into it. Also, for equipment partial surface area, you'll notice here that we document all of the partial surface area and volume calculations that we've implemented so that you're, confident in the results that you're getting. The next item, and this was something someone asked me to cover, was how does it estimate the latent heat? So I showed you, I specified 0 to 1 mole percent that was vaporized. So let's go into what that calculation method is doing. So the first most important thing that is valuable to the results is what the relieving fluid properties are. And in the fire algorithm, HYSYS determines what they are. So the relieving temperature is calculated using a pressure vapor fraction flash to the liquid inventory's bubble point. Then the vapor that would be in equilibrium with that liquid at the bubble point determines the relieving fluid properties of that vapor that's generated when it first starts to vaporize. The relief load calculation is a well-known method in API 521. So those equations are here on the slide. The two values that are underlined in blue, that's the one that the user impacts. So the exposed surface area, that's that equipment calculation I just covered, and the latent heat of vaporization. So for the latent heat estimation, it will not match the latent heat value displayed in HYSYS or in Aspen Plus because it's different. It's specifically intended for relief device sizing. So what we do is we flash the liquid inventory to the initial percent vaporized that you specified. Then we flash it to the final percent vaporized. The heat required divided by the vapor generated gets you the latent heat of vaporization. We do subtract off the sensible heat effects as required by API 521, so we do exclude sensible heat in the calculation. Now, then we went into the semi-dynamic flash algorithm. Now, in the semi-dynamic flash, you can't manually specify the exposed area. You have to give me exactly all the dimensions. The reason is because we use your reference stream to determine your reference stream as well as the liquid level that you specified determine for us how much mass is in the vapor space and how much mass is in the liquid space. Then we do a constant volume flash to relieving conditions because per API you can assume that there's no input or output from your vessel during a fire. Then the relieving temperature is the temperature corresponding to the constant volume flash to relieving pressure. This is the starting point of the series of flashes. So then on the next slide I show that all we do is take that vessel at relieving conditions and we flash it stepwise over 10 flash drums to whatever maximum temperature you specify. And any vapor evolved, we divide that by the time increment to get you your vapor flow rate. So it's a pretty standard calculation recommended by CCPS as well. A lot of companies do use this because it does include sensible heat effects instead of excluding sensible heat. But that's what's going on under the hood of the wetted method. The next thing that I'll go into, and the next three are a little bit quicker. So we're going to describe how to set up systems protected by multiple release devices. So let's go into that. So I'll start with the same simulation that I had before. And this time I'll go back to the PFD. And you'll notice that I have a lot of different scenarios here. And you'll notice that in the summary table, the required orifice area, which we call the calculated orifice, it varies greatly between the sizing case, the one with the largest, and the one with the smallest. And we can zoom in on this if it's hard to see. So what I want to do is I want to have multiple relief devices going off. So I'm going to add a PRD. This is the PRD data tab. Here's where you manage your full set of relief devices. You also can determine if it's a carbon steel, stainless steel construction, and it'll tell you your size and case parameters. Then to really design the system, you go to the rating tab. This is most useful for systems with lots of relief devices. I will select the default API 520 arrangement, and you'll notice that the allowable overpressure for the lowest set valve is automatically updated to 16%. And your size and case scenario is recalculated at the higher overpressure. What's nice about this is I can select the orifice, and what it'll do is select the next orifice size above the calculated. The problem is if I do a 50-50 split, I'm still potentially going to have to worry about some chattering at my low flow scenarios. So what I do is I can change the flow split to maybe 10% and 90%, click select orifice one more time, and you'll notice that I have far fewer concerns. So this is sort of an engineering judgment, whether you're okay with using 50%. I am, so I'm going to stop here and say using 50% of the PSV capacity is pretty good. You really get worried when it gets down into 30, 20, 10%. That's when chattering can really become a real concern. So that's how you set up different valves. For line sizing, it's the same algorithm we've described before, just simply based on equivalent length. And from the drop-down, you can just, differentiate the different inlet and outlet equivalent lengths for each valve. For any rigorous line sizing, you really should be taking your data back to Aspen Flare System Analyzer. And that's what we're going to talk about next. So we just covered setting up systems protected by multiple PSVs, and now we're going to go into taking these results into Aspen Flare System Analyzer. Okay, so in order to take your results to Aspen Flare System Analyzer, you really want to have sort of finished your release system analysis for that portion. I have a file, a demo file, where I've created lots of different release devices with lots of global scenarios, and I happen to have Aspen Flare System Analyzer open. So what I want to do is I want to click File, go to Import Sources, then pick the relief valve sources from the simulator, whether it be Aspen Plus or HYSYS. Both of them can import to FlareNet. Then I browse for the file. So I have this demo file that I created, and I double-click and I upload the file. And what you'll notice that it does is it'll go through, it'll create all of the components used, and it'll also upload any of the PSV sources. I'm going to a plain Flare file, so here I don't have any already created Flare sources. You can also import into already existing Flare headers. So when I type in a number, so I typed in PSV01, you'll notice that it actually will add it to the simulator. So here I'll add PSV02, and here I'll add PSV03. Let's pretend for the time being that all the rest of the PSVs go to a different Flare system, maybe a high-pressure Flare. The next thing I can do right within this import utility is define my global scenarios. So let's say I want to consider cooling water failure. What you would have to potentially do is go through and map every cooling water scenario for this one. That can get tedious, so we have an auto map feature. What you can do is say for the cooling water flare global scenario, I want to map it to anything whose type is cooling water. So here I select cooling water failure, I show the list, and this will show you the results to make sure your filter is appropriate. And you'll see that it finds every cooling water failure scenario in the PSVs from that file. So I click OK. And now I have all of my cooling water failure scenarios already imported. It's only going to import for 1, 2, and 3 here, then I'll click Done. You have the option to save your import set, so if you always want to map every cooling water failure to a cooling water flare global scenario, you can do that. I'm not going to do it right here for the demo. And you'll notice that what you actually get is the PSV newly created with the associated outlet equivalent length. We also import the inlet equivalent length, so I'm going to open up this PSV. So let's open up PSV01. And you'll see that the composition, I forgot to change the global scenario, so it's a default. I care about cooling water because that's what I imported. So if I go to PSV01, the compositions have been imported. So it had a 50-50 mixture of propane and butane, and it imports all the conditions here. So the MAWP is the design pressure, the relieving pressure, the mass flow, the allowable back pressure, all of that is from your simulator. And also the components that were created are also created based on your simulation. So it can save a significant amount of data transfer time. And it can improve your results because you don't have to worry about user error. And then finally, we'll go into just briefly how to generate and customize some documentation. That is an area where I get a lot of questions. So we'll go back to the demo file that I was working in. And we have different types of reports. We have built-in reports where you click a button and it generates a predefined template. So this is a calculation report, which I can't currently zoom in on. But what it defines is any input that went into defining your calculated orifice. So the KDs, the KC, if you have a rupture disc installed upstream, any of the relieving flows, all of that is summarized here. You can't edit the template. It's built in. It's created. In the documentation builder, you have a little bit more customizability. It's not much, but it's a little bit. So what it'll do is it'll open an access. And what you can do is you can view the data sheet. So if I want to view all the process data sheets for every relief device, here it will list all the relief devices, and then you'll get this nice form which goes through and defines the operating conditions, the relieving conditions, whatever you might need to store for your relief device. If you want to edit it, you can actually export it to Excel. So I'm going to just type in some sample file, and we'll open it to see what it looks like. And you'll see it's the same format that you saw before, and it has all the same information formatted. We don't currently have the ability to define the significant digits yet. We are working on improving that, but you can put your logo, you can create macros to try to use this information in some other way. It's very useful, so you can take all of that to Excel. We also have the PSV booklet switchboard. This allows you to select a PSV system, and it allows you to look at all the data summarized for any applicable scenario. So here I had cooling water failure and tube rupture as my applicable scenarios, and it summarizes all the simulation results. If I then type in anything manually, if I want to create some notes, for example, it'll save them with your HYSYS file. So everything is all zipped up and wrapped up in one simulation file. It should be easy for document management as well. So those are the options when documenting and creating custom documentation. There's not a lot that we can do. We are aware people want more, but for now, it's actually a big improvement in a lot of workflows. So I'm going to pass it back to Catherine to finish up the presentation.
Great, thank you, Anna. Those are some great live demonstrations that definitely showed some not only how we utilize the product, but what goes into our calculations. So now that we've addressed the safety analysis workflow, how our products improve it, how we can utilize those products to maximize the most efficient safety analysis workflow, we're now going to go in and really put some proof to our claims and discuss the success story we recently had with an E&C company. So this success story is with HGA. HGA is a mid-sized engineering and construction company out of Louisiana. So HGA, like many of you who are E&C companies, was experiencing an expanding work volume at the same time with the design complexity of their projects also increasing. So HGA looked to achieve their growing business demands through reduction in their project cycle times. So HGA realized that they completed overpressure analysis as a regular part of their design workflow, much like many of you, and they saw this area as one of the key obstacles in their design process, or a bottleneck. So HGA's original overpressure protection analysis, as highlighted at the bottom of this slide, was very similar to the before or purple workflow we demonstrated earlier in this webinar. Their workflow required separate calculations that were done in additional tools, and this resulted in those same pain points we talked about before of manual data transfer. It was tedious, time-consuming, and susceptible to, data transfer error. So at the time of their investigation, HGA realized there weren't really any commercial products available for integrated safety device sizing. However, with the release of the PSV sizing within Aspen HYSYS, HGA found that the integrated functionalities provided really created a tipping point for them to fully upgrade to the Aspen One engineering suite. So after adoption came validation. As many of you know, within the safety industry, validating your tools is very imperative. So HGA was able to validate their calculations they completed in HYSYS against calculations they had on previous work, and they found marked consistencies between the two methods. And after validation came implementation of the product, and HGA was able to streamline the relief sizing workflow from start to finish. You can see, the before screen, or the before image of what the workflow was kind of like before, and then how, streamlined it was after. So we're going to go into some of the benefits that streamlining this workflow really provided HGA. So, as we talked about earlier, manual data transfer is really tedious, and HGA was able to, definitely decrease their manual data transfer with this integration. This reduction in manual data transfer also related to an increase in data accuracy, as that, potential for user error was eliminated. Also, with reduction in manual data transfer, hand in hand, the ability to integrate and automatically export to Aspen Flare System Analyzer, definitely all these different features and all these benefits helped HGA save 50% time savings across their entire relief sizing workflow. These time savings are really important to E&C companies, as I'm sure, and companies in general. As you all are aware, your engineering hours are extremely valuable, and inefficient workflows, there's no time for that. So in addition, HGA also saw benefits as they were able to kind of expand the scope of their relief load calculations to areas such as supercritical relief loads. In addition, we just want to mention, what's great about HGA is that not only were they able to see success, but we were really able to work with them and get some great feedback on what they thought of the product, and that really helps us to work with them and identify areas of development as we're constantly looking to grow and have our product really advance your safety workflows. So, on the tune of, getting feedback and working with customers, this transitions right into our upcoming Viewer's Choice webinar, because this webinar is going to be very interactive. So let's, get some background on that. As I said before, this webinar is coming up soon. It's going to be scheduled for Wednesday, January 28th, 2015, so mark your calendars. What is this webinar? We are going to be taking your questions, your suggestions, your feedback prior to the webinar and design our content and what we answer. Anna went through some great demonstrations today and, showed us a lot. So if you want your questions answered in depth, as we went over some topics today, you should absolutely submit them. We'll we'll pull all of the suggestions and questions, and we'll pick the top most popular ones and answer those rigorously, and then try and answer the rest of your questions through, again, our extended Q&A session at the end of the webinar. So you might be wondering, how do I submit my questions? The best way, and the way we're going to be monitoring, is through our Aspen Tech community. So at this time, in terms of, creating an integrated webinar, we're going to open up a poll question here, and we want to get some of your feedback. So on the right-hand side of your screen, you'll see a poll, and it's talking about, what's your comfort level utilizing the Aspen Tech community? Have you used it before? Are you not comfortable? Are you comfortable? Answer this poll as best as you can, and based on your feedback, we'll kind of go over the steps and get you more in tune with how to use the Aspen Tech community. While you're answering this poll, I just want you to know that in order to post on the community, we've also given you the direct link to the discussion where you'll be submitting your questions. This is listed at the bottom of your screen here. as we mentioned before, this slide deck will be distributed after the webinar, so in a few days you should see this. You can access this link from the slide deck, or we'll be promoting this link through a bunch of different assets, so you can definitely find this direct link. Okay, at this time, it looks like there are some of you who are not as familiar with the Aspen Tech community, so we're just going to kind of jump in and show you how to familiarize yourself and actually be able to post your questions effectively. So we have the direct link, which we listed before, but should you lose that link or you want to access the community post from the aspentech.com/community page, just visit from your web browser, aspentech.com/community, and select the Discussions tab highlighted in green on this slide. From the Discussions tab, you will then click on the View Now link to join the latest engineering discussions. From there, you will click on the discussions on safety and dynamics, and that will bring you to the safety and dynamics page, where you will click on the Cast Your Vote for our Viewer's Choice webinar link. Once you click on this link, you will be brought to the same page where, say you would click the direct link we gave earlier, everyone will be brought to this page. This is your end goal. So this is where you really want to pay attention and learn how to submit your questions. To get your post up there, you simply click Add Reply. And this is where, we find the biggest bottleneck and confusion with the community. So you will then be prompted, you have to log in order to post. You can view anything without logging in, but to post and get your question heard, you have to log in. So if you're not already logged into the community, it'll bring you to this page. So if you're a community member, you will enter your username and password here. However, you do not have to create a community login if you have an Aspen Tech support account. So if you have an Aspen Tech support account, enter your username and password in the fields here, and you will be automatically logged in. You don't have to create a whole new set of credentials. If you have neither of these accounts, you will have to register for an online profile. Just fill out a few fields, and you can join the Aspen Tech community today. So once you have logged in, you'll be brought to this page for the post, and you can just, type your questions, comments, what you want to see answered through the Viewer's Choice webinar, and then click Submit Your Reply. At this point, I just want to, let you know if you have any trouble logging in, accessing the community posting, please reach out to either Anam and I, and more importantly, our community@aspentech.com email address. We have some community experts who are constantly, checking in, answering questions, and they are a great resource. So definitely reach out to any of us. In the spirit of making this an integrated or an interactive webinar, we're now going to open our last poll. And so now that you're familiar with what the Viewer's Choice webinar is and how to post, we want to hear from you. Who plans on posting a topic for this upcoming webinar? So the poll is, again, on your right. We'll give you a minute or so to answer, and this is a great way for us to, follow up with you. If you plan on posting, we have some specific questions regarding your post, or if you're having some trouble accessing the community.
All right, thanks Catherine and Anam for the informative presentation. Before we go into the Q&A, we would like to highlight an upcoming training on, not upcoming, but there is a training on pressure relief analysis using Aspen HYSYS. This is only available on demand, and to inquire on this course, please email the training department, or for a list of comprehensive list of training courses, please visit our website. And to sign up for our upcoming live webinars, visit the Aspen Tech website, click the Events tab, and select Web Seminars. Listed here are upcoming webinars that might be of interest to you. And please note that there are on-demand webinars also available on our website. And should you have any questions on the webinars, please feel free to email me. Okay, so now let us move on to the Q&A session. Please note that there is a floating toolbar on the lower right-hand corner of your screen. To access the Q&A window, click the question mark icon on your floating WebEx toolbar and simply enter your question and send it to all panelists. Now let me introduce our panelists for today's webinar, Mr. Mantra Srinivas, Senior Business Consultant. Srinivas has over 10 years of experience in engineering and operations functions in the oil and gas refinery and petrochemical industry. He holds a master's in project management from the National University of Singapore. All right. I see there were some questions being posed previously. Okay, perhaps we can read the question from Adi Patamina. Can HYSYS perform fire case relief calculation for liquid at supercritical condition?
To respond to this question from Adi, I would say, like, when you say like liquid at supercritical condition, we have to be a bit cautious because liquid is a different condition of state, and supercritical condition is a different state of fluid. So if you understand the way HYSYS performs or generates fluid properties is through a pressure and vapor fraction flash. So okay, the condition could be like liquid is at operating conditions, and at relieving conditions the same fluid can convert to a supercritical fluid. So as you have seen through the webinar, there is a calculation method for separately developed, which is a semi-dynamic method, which is not a dynamic mode method. So we can do that using, we can, like, at operating conditions, HYSYS can develop the properties and generate the properties at liquid condition, and at relieving condition, if the fluid condition is supercritical condition fluid, then it can develop properties at that condition. And coming to the next one is how to calculate relief load when Dyer's analysis is required for fluid for a fire relief scenario. As such, like as I told you earlier, it's more or less a automated procedure within the system, whereas HYSYS does a flash for both the conditions at operating and relieving conditions, and it will identify what are the relieving calculations which are more possible. So Dyer analysis is more towards like two-phase relief conditions, and the semi-dynamic evaluation which you have seen through the procedure is more or less like taken from CCPA chemical. It's a different calculation method apart from Dyer's analysis, because Dyer's analysis assumes the relieving fluid to be, or the two-phase fluid to be homogeneous. So it's only one part of complete Dyer's calculation method. So we have developed a more rigorous calculation method, and it is the latent heat which we get it from this is more accurate compared to the conventional method. So so these are two ways of looking at it, and whether we can use PSC sizing module with others, no. I would say like we will not be able to use PSC sizing module with other softwares, because if you are aware about the past history, PSC sizing was an independent software which has been acquired and integrated into HYSYS to such a level that we have an integrated workflow which is developed within the system. So it's like you have HYSYS to perform process simulation, you have PSV sizing which is integrated within HYSYS to perform PSV sizing, and the properties or the relieving sizing calculations which are done can be seamlessly exported to FlareNet. So this is the integrated workflow which Aspen is looking at, and for your added advantage or for your information, though we have acquired this PSV sizing software from an external company, we are not charging any additional tokens, so it will be as part of basic HYSYS. So that is a point of like advantage you need to look at it, and it's a whole single environment which is being developed and it's being groomed into as the versions are progressing. Then how do you decide when relief from PSV is two-phase or vapor only? Like Mr. Ravi, to answer you, as I told you, like HYSYS does flash calculations both at operating condition, then it will decide what is the relieving. It does the same thing, PV flash. So at operating condition, it will does a check, and relieving conditions can vary something like 10% for multiple relieving scenarios and 21% for fire case scenario. And you could have, I would say, some conditions like where you have multiple valves wherein the relief set pressure is 16%. So in that case also, like, it does a steady state flash calculation at that relieving condition, and that flash will let you know like what is the vapor condition, what is the fluid condition, whether it's a vapor or two-phase, and that comes as an automated feature wherein HYSYS will suggest you what is the I would say, like, it will not suggest you, it will give you a option saying that this is the fluid condition at the relieving point. Then how is the RV sizing database stored individual file of? Okay, it's based on MS Access database. So whatever sizing calculations which we do are stored using MS Access database. But unfortunately, for your understanding, that these two are inseparable. So as long as you have your HYSYS, the Access database will be along with the HYSYS. So if you see like earlier versions of version 7 and earlier, the file name was HSC for a HYSYS file case. But version 8 onwards or 8.0 onwards, the file name has changed because it is all new, a composite file structure, and that is one of the reasons we have adapted the Microsoft file structure. So we are looking at like integrating the multiple softwares and multiple tools which are available for our advantage. Then for unweighted fire case, you have shown supercritical condition. Yes. Then there is another question regarding supercritical condition. Is it necessary that always it is a supercritical? It doesn't have to be supercritical, Mr. Amit. Okay. If you see the phase envelope, then like the fluid moves from a liquid condition to a vapor condition, and from vapor to gas, and gas to supercritical condition. So when you do a flash calculation, then you are doing flash calculation at 2 points, one at operating point and one at a relieving point. So if you see the drop down for unweighted case, there are two options. One is unweighted API and supercritical fluid. So when you select unweighted API, you assume that you have vapor and there's no liquid flow coming in the feed, and the calculation is done as per unweighted API formula. And when you choose a supercritical, then you are aware that your fluid is supercritical fluid, and the system or the software will follow the algorithm which is more specific to the supercritical. So it's like a semi-dynamic rigorous calculation which is to be performed, and it is like an iterative process which goes by. So you have to define how many iterations you need to perform. So it, more or less, because we have seen the semi-dynamic flash for a liquid vaporization for fire case. So this is also more or less similar to that. This iterative process for supercritical fluid is more or less similar to that calculation. So HYSYS will suggest you whether it's supercritical fluid or not. Then you move on selecting which possible option you want to follow.
Okay, Srinivas, perhaps you'd like to address this question. Last question from Aditya Narayan.
Aditya Narayan, this question says like, would like to know if dynamic simulation can be used for relief property estimation. I'm not sure, like, Adi, what you are looking at, and I've already replied online, but this is for information of all the listeners or the participants. So the way we have developed the workflow is like first we set up the property model, define the components, move to steady state mode. Then we size our relief devices all in steady state mode. So once we have sizing calculations confirmed, then we have already sized the orifice, and then whatever PSC sizing we have been talking all the while is done in a steady state mode. So once your orifice is defined, then we can move to a safety or sensitivity analysis in a dynamic mode. So the question you have asked is like, I don't see any relevance to the workflow which is there. But to answer your question, which I've stressed upon multiple times during the discussion, is also like HYSYS and even Aspen Plus for 8.6 onwards will estimate properties at multiple relieving scenarios, as I told you, like, and these are steady state point conditions. So one point where HYSYS develops properties is at operating conditions when it does a normal flash during modeling. Then at plus 10% overpressure condition and plus 21% overpressure condition. And if you are aware that since version 8.6 we have multiple valve sizing also, and there could be a analysis wherein like your overpressure condition is plus 16% as per API. So HYSYS or Aspen Plus, they develop properties at a steady state condition at these operating conditions. So apart from that, like a dynamic simulation or dynamic analysis is a different ball game together, which comes at a later part once your relief valves are sized. Hope I think answer you.
All right. Thanks everyone for your participation, and Srinivas for your comprehensive answers. Just before I close off, I just wanted to remind you, a few of you all have asked for the presentation of today's webinar. Just to remind you that at the end of today's webinar, there will be a short survey. And for those attendees listening to the webinar in the room, kindly ensure that you reflect the accurate numbers of listeners in your survey form. And after completion of the survey form, you'll receive a copy of the webinar presentation as well as the webinar replay link within a week. All right, so thank you very much, everyone, for attending today's webinar. And we look forward to seeing you at our next webinar. Thank you. Bye.
See you.